The minimum circuit ampacity, or markup, does include a safety margin. Unfortunately, without more detailed information, such as the unit's power factor and efficiency, it's not possible to calculate the exact current drawn accurately. However, you can make an approximation. Firstly, estimate the power factor. Rooftop units typically have a power factor of 0.85 to 0.95. If unavailable, assume a power factor of 0.90. Secondly, calculate the apparent power in volt amps or VA. The formula is VA equals power in watts divided by the power factor. R in watts is not provided in your given information. For estimation purposes, you can use the nominal cooling capacity of the rooftop unit. Thirdly, calculate the current in amps. The formula is amps equals VA divided by voltage multiplied by the square root of 3 multiplied by the number of phases. Voltage is given in your information. The number of phases is typically 103. As an example, assume a rooftop unit with 20 tons of cooling capacity. Typical power per ton is 1 kilowatt. Power in watts equals 20 tons multiplied by 1 kilowatt per ton, which equals 20,000 watts. Assume a power factor of 0.90. Assume a voltage of 208 volts. Assume a number of phases of 1. Therefore, the calculation is as follows. VA equals 20,000 watts divided by 0.90, which equals 22,222 VA. Amps equals 22,222 VA divided by 208 volts multiplied by the square root of 3 multiplied by 1, which equals 41.22 amps. Note that this is an approximation. For a more accurate calculation, contact the manufacturer or use a load calculation software that considers the specific unit's characteristics. When selecting the feeder size, it's generally advisable to add a safety margin of 10 to 20% to account for potential variations in load or future additions. However, if the current drawn is estimated to be significantly lower than the MCA, you may consider using a smaller feeder size. Always consult with a qualified electrician or consult the applicable electrical codes before sizing the panel and feeder.